All right, today we have a lot to cover. Not only did we take about 10 days away from this project to let the progress move along, but we've also seen one of Vancouver's worst weather storms in history. So anyways, let's get into the project and see what we've done. And let's start off with walk through the house, showing you how the progress of the rough-ins have taken place. We mentioned right from the beginning of the rough-ins that HVAC guys go first because they occupy the biggest footprint of the rough-ins in the entire house. We need them to have the flexibility, we need to have the open movement without anybody interrupting their paths for their ducting, and I'll tell you why. Have a look here. This represents ducting that goes from the remote location, passes all through this bathroom, ends up in the second bathroom. You see how much runs are involved just for the HRV units, right? If you were to put these guys later, they will be in big trouble because the size of their ducting determines the space that they occupy. This is just one of the sections. Check out the areas where the equipment gets installed. Now, this equipment recently got delivered to site. These are Mitsubishi air handlers, which took a little bit of time to get in, but check out the size of this equipment and check out how difficult it is to work, especially in customized locations. This is actually above the future laundry machine. So in order to get this type of equipment in, they'll have to create the space, run their ductwork, wait for the equipment to come in, order the size of the plenum boxes after the equipment gets installed, wait for that plenum box to come in, and then customize every connection to the unit itself. While this ordering is taking place, all the rough-ins can go on. Meanwhile, all the other trades can finish their jobs. So now we're at the point where all the trades are finished and the final connections to the units are taking place. And now we'll finalize all of our rough-ins. There's one thing to note when installing these type of units. We always have to keep in mind fire stopping. A lot of these units, because they're hung below the ceiling, we have to remember that in the areas where drop ceilings take place, there's also space above that flat surface area, which we have to protect, because above this area exists spray foam. And in order to protect the spray foam, which is a flammable product, we have to line the areas with drywall as if the full ceiling's in place. Check over here. All the ductwork runs right through drywall. All the seams are taped so that we don't have any chance of having fire escape from this level to the roof areas. That concept applies to every area, despite whether there is a machine or not. Any areas where we have a drop ceiling, we always encourage to have that area lined with drywall. It's just the easiest way to maintain the continuity of the fire stopping. As you can see here, this is actually the top of the closet, but past the closet, you still have a drywall ceiling. So it's good to allow that little bit of a space up top. You'll see that we slid the 1/2-inch drywall between the drop ceiling area to allow for a full continuity of the fire stopping and the drywall ceiling. What you don't want to have is drywall come up to here, come down, go across, and come down again. Fire stopping can be maintained, but it's not continuous as you would like it to be. Let's move on to the plumbing system. So we mentioned that this house has a radiant floor heating system, and given the nature of the flat roof, it makes it very difficult to run everything where you want it to run. For example, we have our future boilers up in the roof in the doghouse area. But in order to get the pipes down from the doghouse, you gotta pass through a series of beams. In this house, having a flat roof, beams are everywhere, crisscrossing, overlapping each other, pretty much creating dead ends everywhere you go. And if you are familiar with the structure of the house, you cannot necessarily drill where you want to, especially in beams. Therefore, there could be a situation where you're running pipes around beams. In this case, we had to run pipes on the outside walls. There's a rule when it comes to running pipes that contain water on the outside. Always provide the adequate insulation that's necessary to protect these pipes from freezing and bursting. How we address this is we put high density foam, isoboard, behind this area because that gives a higher density R value when compared with using just a regular batt insulation or rock salt. And in addition to that, on the outside, we do have 1.5 inches of rock salt, which adds to the overall R value of the wall. But to protect this immediate area, we would provide a isoboard lining this entire joist cavity so that we would protect these pipes from bursting in the event that freezing takes place. Now, another location where that pipe protection occurs is behind this waterline areas. You see, these are the wall-mounted faucets. You see there's water lines running behind this wall area, and that's why we have isoboard in place to protect this. In addition to this isoboard, we also have a layer of bad insulation or Roxo, which we'll be adding to the R value again. And again, the outside will have an 1.5 inches to protect it. This is what you want to present when it comes to having insulated areas behind water blinds. On the topic of pipe protection and protecting pipes from freezing, the ultimate assembly would actually entail that you build a separate wall completely isolating the areas that are insulated with vapor barrier and the actual area where you run the pipes. So we'll call this a service cavity, giving us an opportunity to run all the plumbing pipes separate from the walls, leaving this vapor barrier continuous and this area completely separate so that insulation does its job and this wall does its job by allowing us to run all the pipes that we need inside the conditioned area. Just before we leave the master ensuite area, we talked about in the last video how sprinkler systems work. The water inside the sprinkler systems is actually charged with water from a flush toilet. Every time you flush a toilet, the water from the sprinkler system goes into the pipe that feeds the flushing mechanism, and that's water that flushes out, giving a constant recirc of the water that's inside the sprinklers so it never gets stale. Well, how that works, this is the pipe feeding the sprinkler system. So this pipe actually ties off of one of the sprinkler heads from downstairs. It provides water supply under pressure. It will attach to this pipe via a pressure regulator because you want to make sure the pressure from the sprinkler system gets translated into a working pressure that's good for the plumbing system. From there, water goes from here, travels to the toilet, ready for use when you flush it. The moment you flush it, the water releases from the sprinkler system through the PRV, travels up here, and discharges through into the toilet and out the drain. One last thing, I promise, before we leave the master ensuite, I want to show you kind of a feature for this house. We're using a special ventilation system when it comes to exhausting the stale air from the bathroom. Now, typically you'd use a bathroom fan, you know, like a 12-inch by 12-inch. What we don't want to introduce into any house is unnecessary penetrations. Typical to every bathroom is a bathroom fan that goes outside. Now, you can imagine that every time you turn on that bathroom fan, you're consistently taking out conditioned air, meaning it could be cooled air or it could be heated air that you paid to condition to that temperature. The last thing you want to do is throw back outside. What we have in this project, we have an HRV tied to the bathroom exhaust system where we have a POSH system. This is a patented system by Energy Products whereby the HRV takes away the stale air from all of the bathrooms back into the HRV and sends it outside. Now you're going to ask, is this enough ventilation for each bathroom? Because we have a steam shower here. We have a typical bathroom stale air which you want to get rid of. Well, this type of system is always running. POSH gives it the ability to control how much airflow when it's in use. Under normal use, the POSH grill was going to be down just enough to have a certain constant CFM airflow constantly being exhausted out of the bathroom. When you push the button to activate higher capacity airflow, what happens is that grill drops down further, allowing more airflow to escape into the system and stale air exhausted than regular. And that's usually based on the timer. It could be 15 to 20 minutes. But during that time, the machine ramps up for this area only and only for this bathroom so that the larger HRV unit can concentrate on the areas that are being used. So the normal flow of extraction would be, say, 25 CFMs. Under use, if you push the button to activate the machine, it might be like a 60 or 80 or 90 CFM extraction, depending on how the machine is programmed. That's called a POSH system. I use it for every single one of my houses. David Hill, the creator of the system from Energy Products, excellent product, and I encourage builders to check it out, see if it fits for their projects. But this is how you limit the amount of penetrations, especially from bathroom fans throughout the house. Let's talk about the low voltage system. Right here we have a structured box. All the critical wires, all the Cat5 data, alarm, camera wires, are all brought centrally into one location. So this is where you'd mount your modems, you mount all your Wi-Fi equipments, and centralized so it's easy for access, it's out of the way, and nice and convenient for any service technician to come to do all the servicing. Earlier on, we also talked about the electrical system and how we have a single keypad that operates multiple lights within a room. Let's go talk about that system and how it's integrated into this house. Many different areas of lights concentrated in one area, but I only have one little keypad to control all of them. This keypad will come in form of 6 buttons. For example, the first one's programmed to turn on the lights within the main floor, the entrance area. Second light will be the office. Third button will be for the staircase, and so on and so forth. What I want to point out here is it's only one set of wires that gives the keypad the power. Within this keypad is a remote control which controls all of the lighting in this area on a remote panel. Once I push the button on this keypad, it activates the switch which is installed at a different location. So let's go check out where those switches are installed and how they're controlled. So this setup right here represents the Lutron system and how we plan on putting all of our remote switches. Each 4-gang box represents 4 separate switches for 4 different areas, and we see we have 5 packs of them. So one keypad can easily control multiple sets of lights through here. When you push the button on the keypad, it'll be programmed to either operate one set of wires or multiple set of wires. But the remote switches are located somewhere away from the centralized area. Otherwise, if I were to do it the traditional way, I'd open the door of the house and I'd immediately see 5 switches rather than 1. And I'll have less flexibility to control more than that because I'm limited to how many switches can be fit on one box in that one location. By having that single keypad, we save space, we increase the aesthetics of the house, and we also increase the flexibility of how many different areas we can control at the same time. The system is called Lutron, and the actual name of it is Lutron RA2. Now it's going to become RA3. So we're yet to finish off the rough-ins, but in the meantime, let's check out all the progress that's been made on the outside. All right, let's talk about the outside of the garage for a second. So we're standing inside the garage where the electrical service mast has been installed, and you'll notice here that everything's mounted straight to the siding. It's typical for a lot of houses in the city to have a big piece of fascia board mounted behind this equipment, and everything gets mounted on top of that fascia board. But the end product doesn't look as nice because you see a big bulky piece of wood here where the siding butts against. I'm a little bit against that look because it doesn't show as nice and clean. So what we've done for this one, which is twice as much work, is we prepared the backside of where we're going to mount these clamps. We prepared them with reinforcements as necessary so we don't have to have that bulky fascia to mount to. So working a bit of backwards and then going forward and working backwards again and going forward, we came out with this final product where, if you can see here, everything's mounted on the surface, nice and clean, no interruptions, and we have a much cleaner install. Once it's painted, you see a dark background and all the electrical equipment mounted on top, giving you a nice, clean, minimalistic look. So one of the inspections that took place in the last couple of weeks was called the Sheathing Inspection. And this is where the city comes out and inspects all the nailing pattern for your plywoods. They inspect all the paperwork by the structural engineers. They make sure that the labels and the windows are correct with their USI values. They make sure the windows and doors are in place. And then they give you the okay to paper the house, we call it. That's when you can apply the membranes across the entire surface area of the outside of the house and prepare for, in our case, the outsolation and then the final cladding. Now, in this case, we chose a Sega product, and believe it or not, we're the first project in Vancouver to use the Sega SA500 2.0 system. The 1.0 system was pretty good. The new product came out, and we're fortunate enough to be the first house to use it. The 2.0 gives us extra adhesiveness to the backside of the membrane, and as usual, Sega performs really well. I use it for all my projects. I'm glad to see that they chose us as the house to test it on. Notice all the joints are taped. We have a closer look on the side of the house. This material is self-adherent membrane. It goes right into the wall. It's stuck very nice and tight. This is where it's important because you don't want to have any mechanically fastened products which could allow air to travel behind. In this case, the material is stuck onto the surface and it's continuous right to the top. All the vertical seams are taped, and where the penetrations come off the wall, it's all prepared behind and overlap to shingle effect any water that might come in this area. So this area is not finished yet. You'll see some penetrations that are still in question, but for the sake of getting this house watertight, we get this whole wall done first, move to the other side, front and back, get the city to come inspect the membrane, and then we move forward with the outsolation that gets mounted on top of this. We spoke about 2 inspections that had to take place: sheathing inspection and window mock-up. In this case, we chose 1 window in the entire project to mock up, meaning that we'll assemble this area in a way where we will be assembling the rest of the windows and doors. So we have to display to the inspector what type of system, rain screen, outsolation, and membrane we'll be using as an example. And then he would come out and inspect it and give us the okay to go ahead. In this case, the building envelope engineer came out, give us the approval, paperwork goes to the inspector, he likes it, and then we're allowed to continue with this system for the rest of the house. Of course, once he sees that the paper or the membrane has been installed throughout. So let me describe to you the system that we intend to use for this house. First of all, we have a premium product, the Sega SA500, which is our base layer WRB. Next, we have 1.5 inch Roxol, which acts as the sweater of the house. It adds an extra layer of insulation on the outside, continuous, so we don't have any thermal breaks. Because if you were just to rely on the insulation within the walls, then you have a thermal transfer from the wood to the outside, and With this system in place, it reduces or eliminates the amount of thermal transfer. Next, we have the rain screen that will be installed on top of here. So in the event that any water gets behind, it has a chance to travel down. So this compresses against the WRB, this compresses against the Roxo. This product does have a little bit of a softness to it, even though it's a rigid material. So it can deflect a bit when you fasten it. It's very careful when you do install these rain screens that you're not compressing it too much, because you don't want your walls to be wavy. So always have a good installer to know, one, that he's hitting a stud with the fasteners, and second, not to create an effect like this so that you can see it later on when the cladding goes on. On the bottom, we have a stainless steel bug mesh. Some people like to use the soft fabric material. I like to use a solid one. It's just better for durability. And so this fits right into the pockets. The cladding fits right over top of this. Just imagine there's gonna be a whole bunch of these 1x4s mounted at every stud space throughout the wall. It's very important to remember that this is fastened into the stud, because the requirements are that each screw must penetrate about 3 inches of material on top of that and be embedded 1 inch into the stud, because now we have such an offset of the materials away from the structural members of the house. By getting into the stud, you're actually increasing the rigidity of this whole assembly. When you uniformly distribute this whole system out, it creates a nice whole assembly that you can rely on with a lot of good support. Moving on over to the penetrations of the house. In the last house I had a different detail where this exhaust were mounted in the concrete area, where it would core a hole and slip it through and mount it on the concrete. In this case, the concrete walls were much lower than where the floor package sat. So we have to be a bit more creative with how and where we put these vents. In this case, it's against wood. Normally, I don't like to put this against wood. And the typical detail would involve a big fascia board trim around here with special flashings, basically making this look like a big square every time you have a penetration coming out, whether it's an electrical box, a hose bib, or a vent. I wanted to mimic the same kind of detail as a window. Notice that I have a very, very thin profile of flashing surrounding it. It still acts as a protection against water and weather protection, yet it matches the very minimalistic fin detail we have with the windows. Notice this is just a fin and everything butts up against it. So the final product, you'll just see this one nice razor blade thin of a flashing separating this material assembly and the window assembly. And the same thing will be repeated here. As you can see, this is very, very thin profile. You'll barely even notice it once the siding hits it. But it's much more pleasant to look at than if you had a big fascia board surrounding it with all the comb face and all the traditional look that may not look as appropriate on a modern house. Now, we had some really interesting weather patterns in the last couple of weeks, including a very, very big rainstorm that lasted for almost a week. Fortunately, we kept this entire project watertight from the moment we had the roof torch on done, and we managed to get through this whole rainstorm completely dry inside. And we were lucky enough to also have the membrane on just in time so that our walls were kept dry. So as part of keeping the house dry, let's go check out the roof area where the roof panels have started to get installed, and they look really, really nice. All right, we're at the top of the roof right now, and I want to show you these panels that we've started getting installed. These are standing seam panels in charcoal gray. They've been custom made for this project that run around the entire top part of this roof. Now, this roof acts more than just a roof. It actually ties into the fascia system on the side of the house, and the fascia system ties into the gutter system. To make this look good, one, all the materials have to be the same color. Secondly, the function of the roof and the gutter have to be tied in so that the water runs off the roof, gets wrapped in the gutter system where it's hooked, and the gutter takes over from there, taking the drips of water that slide off of this roof. We'll take a closer look once we get access on some ladder jacks and get pumped up to the top. But for now, just get it from bird's eye view how this roofing system comes in together, and look at how nice it ties in with the rest of the shape of this roof line. All right, I'm with Lee. Lee's one of the oldest tradesmen that I know that I've been working with. He's been working roofing for how long?
43 years.
43 years. Okay, that's a long time. You must have seen generations of changes in roofing, and you must know everything about roofing.
Almost.
Almost, okay. Lee, tell me what's the most important thing when using this type of roofing system for any house?
Actually, this is a system we've been using for the government's job. In nowadays, residential housing, they start to use this kind of snap lock. It lasts, I think, 45 or 50 years at least.
Is this a superior roof compared to a standard roof?
Yeah, It's a spiral roofing we have nowadays.
So this roof isn't just sloped. It's sloped, it comes around a corner, it comes up a little wall, it wraps. How do you deal with so many angles when it comes to this roof? And how do you even start?
It's really hard to explain, but it's my, like I've been doing this, I know which step I'm supposed to do first. You have to do layers and the laps on the right way, and everything will be okay.
So for something like this, I mean, I do see lots of corners, saddles have to be made, custom pieces have to be made. It's quite challenging for a house like this.
Yeah.
Well, I see in this project you started with fascias, and
Yeah.
and that's almost at the very bottom. Is there a reason why you start from the bottom and not from the top to the bottom?
When you do this kind of roofing, right, single roof, you have to start from the bottom up. So that way you have everything lapped the right way.
Looks like you have a lot of materials to install here. Lee, I'll let you get on with your work, but I can't wait to see all the details that come with your work. And I'm just going to come back we'll come back around again with a video, and we'll give them a nice feature on all your work. Once it's
Yeah,
done.
you can see right now, right? It's right there.
Okay.
You can see we do like a one step at a time, right?
Okay. Okay, let's start in this corner.
Yeah.
Walk me through this, Lee.
Counter flashing on the bottom there first. How it's supposed to be going like that.
That's beautiful.
Yeah.
Look at that.
And
You folded all that on site?
oh yeah, make everything by hand. All right. And then later on we finish two sides, and then we start to do the back pan. All right. And then with a hook, and the next panel will go on from here and lap on the right way.
So everything's lap, so the water runs downhill.
Yes.
Perfect.
All right.
Okay.
And below there, the counter flashing, we have the venting.
This is the venting strip you put, right?
Yeah.
Okay.
Right below there, so it hooked up too. So there's a venting right on the bottom of the skyline.
When you see a roof that's cladded with metal roofing, it looks a lot more simpler than when you actually install it. A lot to think about.
Yeah.
Okay.
Yeah. Very much, you look at that tile roof over there, right? It's very much the same. Basically, you have to start from the bottom up.
Start from bottom. Okay.
So that way you have all the lap on the right way, and that's how the rain won't get inside the house.
Okay. Lee, I can't wait to showcase everything you've done. How much longer do you think you'll be before you finish this area?
The hardest is this guy.
Okay.
You have to do it right. Right. And after this one, everything else will be very easy.
Okay.
Yeah.
Okay. Looking forward to it. Thanks, Lee.
You're welcome.
So we covered quite a bit in this episode. The next inspection that's going to take place are all the trades inspections. Once we finish that, we can start calling for framing inspection. That's when we get all the final documents that certify everything behind the walls is complete and approved, and then we can start insulating. So that'll be another couple of days, fine tune everything. We do double checks on everything we've done so far, make sure everything's according to the interior design drawings as well. And then we have the confidence to button up the place and move forward with the air tightness, the insulation, all that good stuff. Till then,